All right, so 1, 2, 3, go. There it is. All right, so you've got 3x over y squared plus x over y squared. The reason is that y to the minus 2 becomes 1 over y squared.
Uh-huh.
And you have this x, so you can treat it as, well, if it's x times y squared, then it's x times 1 over y squared, and that x can go in the numerator like that. Is that okay? I did that or
Yeah.
not? Okay.
Yeah.
Now, because the bottoms are the same, you can add the tops. So this is 4x over.
Yeah, that's what I got.
Perfect. All right. Where should we go from here?
We can just go from number 6 and so
Okay.
forth.
All right. Sounds good. Let me know as always if you want one like any of the ones that we're doing. All right. All right. In 3 hours, James read 18 pages of his history book. It's a lot of time to read a history book. In 4 hours, he read 21 pages. I think we're to mean that he read 3 more pages than the 18. Just assume that.
Yeah.
Write the equation of the line that passes through the 2 points that represent the data in this problem. Predict how many pages he will read in 6 hours. All right. So you have to decide what is the input and what is the output. And our options are time, time, and pages. Like which leads to which?
I mean, the time leads to or
Yes.
yeah, that's
Don't
obvious.
don't doubt yourself. Just reason it out. Your time leads to pages. So that's your x value. That's your y value. So 3. We've got two order pairs: 3, 18, and then 4, 21. Right. Do you remember the slope formula from last time?
X2 or y2 minus y1 over x2 minus x1.
Yeah. Okay. Can you attempt to calculate the slope for us, please, on that front?
Yeah.
How are you doing on that one?
Give me 1 sec.
Sure.
So 3 over 1.
Yes. Slope is 3. So if we write y equals mx plus b, the slope is 3. Okay. And to find b, you need an x and a y. So you have to choose one equation or the other. I like the first equation.
Yeah.
So I'm gonna write 18 in for y, 3 in for x. Go ahead and solve that for b for us, please.
Okay. So it's 9 minus 9. So 9 is equal to b.
B is 9, so that goes back into this right here. So your equation is 3x plus 9. And then that's the equation. So that's the equation. We've done that. Check. Now we're going to use the equation to predict how many pages James will read in 6 hours. Is 6x or is 6y in this case?
6 is x.
That's right. So we're going to put 6 in for x, where x equals 6, y equals 3 times 6 plus 9, which is 27 pages.
Yeah. All right, we can move on.
Got it. Okay. If I could just find it, there it is. All right, so 7 and 8 are inequalities. Solve the inequality, okay. So our goal, and we're looking at the side with the variable, so you're looking at 7 minus 3 there. You want to get z by itself. I'm sorry, z minus 3, not 7 minus 3. You want to get z by itself. How do you undo subtraction by 3?
Addition by 3.
Yes. Both sides. Z is equal to 13.
Yeah.
Why don't you try 8? It's exactly kind of the same in a lot of ways.
Okay. Z minus 5 is less than -2. Plus 5 on both sides. So 2 is greater than 3. Or no, sorry, 2 is less than 3.
So here's what I just heard. Is this what you meant?
Yeah.
Why is it that on the left we have a variable, but on the right we do not? Maybe you meant
Oh,
z?
yeah.
I'm not sure. That's why I'm asking, because I don't know where to go with this.
Yeah. It's because I read my Z's really weird. I don't know why.
Okay. Yeah.
I meant a Z.
You can go with the cursive Z. I don't know if they still do that. That's it's a big one. I mean, sometimes I put a little thing through it.
Yeah. Yes. That's what my teacher does. I should. My bad.
Yeah. If you don't like the variable, you can switch it too, and then just switch it back at the end. But that's just some ideas. Okay. On to 9 here. All right, stem and leaf plots. Stem and leaf plots show the number of cards each member of a baseball card enthusiast club has. What is the mode? Modes could be plural of the data. Do you remember what mode refers to in a data set?
Like what shows up the most?
Most often.
Yeah.
And there could be more than one. So that's why it says parentheses S there. What you're looking for in the leaf side is duplication. Like for example, here, see how 7 and 7 are duplicated there?
Yeah.
That means there's 2, and we go to what the key means. That means there's 2 317s. Okay, but we want the one that's duplicated the most. So do you see one that's duplicated the most here?
Yeah, 365. Or 364. And 366.
Yes.
356, sorry.
Yeah, so there are 2 modes in the data set.
Yeah. So would you say that the modes are 4 and 6?
No, you use the key to determine like you just did. It's 324 and 356.
Yeah.
So you want the of the data refers to the untransformed data.
Okay. Yeah, I'm good on that one. We can move on.
All right. Two subway trains run through a station. One train goes through the station every 44 minutes, and the other train goes to the station every 28 minutes. If they just went through the station at the same time, how many minutes will it be until the next time they're both at the station at the same time? All right. This is probably a good problem for me to ask you to try to explain what you see here in your own words, or what you and it's okay if you need to read it again, look at it again, but I'd like to see what you can kind of infer or take from this problem.
Yeah, let me just read it one more time. One train goes to the station every 44 minutes. The other train goes to the station every 28 minutes. If they just went to the station at the same time, how many minutes would it be until they were both stationed at the same time? So, I mean, it's asking us where, like, they intersect in like time-wise, I guess.
Yes, yes. Now, believe it or not, a circle is kind of a cool way of looking at this problem.
Yeah, like
So
a Venn diagram.
yeah, it's like they're concentric circles. It's like one of them is faster than the other. Okay, so like the one that gets there every 28 minutes is the smaller one. And then the bigger one is every 44 minutes. And at some point, like, cause you're just standing there, you don't really care what's happening, but at some point they come back.
Uh-huh.
All right. So the solution to this can be done a lot of ways. I actually don't have a very elegant solution, but it's like it's finding what's called the least common multiple of
Uh-huh.
28 and 44. And there's a couple of ways to do it. One is to do what's called a factor ladder or factor tree of each. And the other is just sit there and start writing out the multiples until they hit,
Yeah.
which you can see gets a little tiresome.
Okay.
Okay, so do you want to do the factor ladder approach?
Yeah, sure.
Okay, so the way this works is you start with 28, so it's 2, 14, 2 and 7, 7 and 1, and then you do the same thing for 44, 2 and 22. The reason I'm starting with 2 is it's the smallest prime number, 2 and 11, 11 and 1. So you start with the first number, and your least common multiple has a 2 times a 2 times a 7. It's got to be at least the smaller number. Then you look at the next number and you see what you already have. Do you already have a 2 in yours? Yeah. Do you already have a second 2 in yours? Yeah. But do you have an 11? No. So that is your LCM. You probably learned this at some point and then didn't use it for a while. It's actually a pretty good problem to do it with. But you just multiply those out. And it's 308. And that is the solution.
Okay. Makes sense.
Makes sense?
Yeah.
If you show the circle, you might get an attaboy in class tomorrow or something.
Yeah.
All right, back to problems here. 12, 11. We do 11. Can't do them out of order. Oh, this is horrible. Box and whisker plots by hand. So in the real world, people never do these by hand. We go to software and we just let the software do it. So this is a little bit frustrating, but we can do it here. So for box and whisker plot, you need the min, the max, and the median. Min, the max, and the median. Okay, which really means like lining up all these data points in order. But because they've got tallies, I guess we can do it without doing that. There's just a lot here. So let's just add up the tallies. 4 plus 2 plus 6 plus 3 plus 7 plus 5. So that's 37. No, 27. Does that sound right to you?
Yeah.
So think if there's 27 numbers, the middle number is the median. That's the 14th number. So to get the 14th, you go 4 plus 2 plus 6. That gets you to the 12th. So 75 is the third is the 14th number is 75 because you go back past the first 4, next 2, next 6. That gets you to 12, and then the 13th and 14th is here at 75. So your median is 75. Your what's called quartile 1 is the middle value from the 1st to the 13th.
Yeah.
So it's in this case looks like it's the or maybe it's the 7th. I don't know if it matters here. I gotta look this up because I don't remember if it's I don't remember if you go 1 to 13 or you go 1 to 14th and find the middle one.
I think actually, I don't know. I do remember doing these, but I didn't see them in a problem sense.
And I think it makes a difference here because if we choose the 7th is 60 because you got 4 plus 2, that's 6. You're 60. But if it's the 7th and 8th, well, I guess it doesn't matter. So because they end up being the same. Okay. So quartile 3 is going the other way. So it's easier to kind of work backwards and go backwards 7. So if you go backwards 7, you got 5 and then 2 more. So quartile 3 is 80. And then the min and the max are pretty easy to find. That's 25 and 100. So you need those 5 numbers.
Uh-huh.
So then you start by graphing the median. So you just say, okay, that's 75. Actually, let me put that between the 2 grids here. That'll be a little better. And then let's just pretend like each of these widths here is 10. So to get to the Q1, we're going to here. That's 60. That's a box and a half or 15. And then for Q3, we're going to 80, which is right there. And then, so that's the box part. The whisker part, if you have animals, you've seen whiskers, you're going out to 100. So 100 is right there. So we're going out by 10 each time. And then Q1 is 25. So we got out quite always 50, 40, 30. Right there's 20, 25.
Yeah. 25. Dang. Okay.
That is it. That does it for that one.
Is there a B part or my?
Yeah, so we've actually done that here, and I'll label those for you.
Yeah, those are the lower. Yeah, okay.
So the usually you do that part first, so you can't do the box anyway. The lower extreme is the min.
Uh-huh.
The lower quartile is what's called Q1. Upper quartile is Q3, and upper extreme is the max. So we have all those 100, 80, 75, 60, and 25 there for those.
Uh-huh. All right, we can move on.
All right. Another one that's just sort of these are all good questions. There's just a lot of like, got to go back and figure these things out. So identify a statement 2 as the converse, inverse, or contrapositive of statement 1 if the truth value of each statement. So typically it's like this P then Q business.
Yeah.
Okay. Unfortunately, this one says not a polygon. So sometimes it would be labeled like this with a little twiddle thing right there. I'm not quite sure, but we need to actually go and look at statement 2 to see how it changes.
Mhm.
So statement 2 says if a figure is a polygon, so that becomes P, then, and I'm sorry, and this is not a square, so not Q, then it is a say that again.
No, I'm just reading it.
Okay, sorry. And you're not, here's the thing, you're not looking to see if it actually makes any sense logically. You're just looking at how the statements are formed. If a figure is not a polygon, then it is not a square. Not P, not a polygon, not square, not Q. Polygon P, then it is a square. Normally, you start out right here with the P then Q and go kind of this direction to figure it out. So this one is, because it's the same order, I believe it's called the inverse.
Yeah.
The converse and contrapositive are something else. We can talk about those if we need to at a later time.
Yeah, I think contrapositive is just like it's inverse, but they're also switched. And then
Yes.
yeah.
All right, so 13 here, I'm going to show you a way to do these problems that might be different than what you have seen in class. 2 students solved the inequality x plus 2 less than 3. Notice that I have not snipped in their work. What I want you to do is to solve this like we did in 7 and 8. How do you solve this for x?
Subtract 2 from both sides. Like X is less than 1.
Yes, so subtract 2, x is less than 1. So the reason I like doing it correctly is so that when we look at each of them, you can more quickly find the error rather than looking at their work. You can say, okay, well, does this match what I did? And the answer is no, it did not. What's different about what you did and what they did? Because yours is correct and we know theirs is wrong.
They added 2 instead of
Yes.
subtracting.
Yes. So in this case, A is wrong. You just said it. They added 2 instead of subtracting 2.
Yeah.
And then B is correct. All right. On to 14.
Yeah.
All right. Remember we worked on the histograms last time. I was asking you about the width or the number of big buckets. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this one, there's a couple ways to do it that I've seen over my time. Is like the square root of the number of numbers, but you need to know the number of bins. The bins are the ones where you put these numbers into, and that's what I don't know here. Do you did you get any guidance on that in class?
Sorry. I mean, yeah, I mean, like we did this lesson, but I'm not completely sure. Like, like how many bins we have per like data set?
Let me try to explain it here in a better way. Let's just say we had one bin. Okay. Like think about when you're a kid and you had a toy box and you just throw all the numbers in the bin. Right? That doesn't work. That's ridiculous. But that's what I'm referring to when I say a bin. The second option is let's just say 2 bins. Okay. So the min here is what, 21, and the max here is 34. Does that look right to you?
Sorry, one more time.
The min looks like it's 21, the max is
Yeah,
34.
sorry.
Okay, so let's say we did a bin from like 21 to 26.5, and then a bin from 27 to 34.5. That didn't quite do this right. Let me adjust this. 27, 27.5, and then 28 to 34.5. Okay, so these are your bins here. So like the 25 would go in the first one, the 30 would go in the second one, the 24 in the first one, the 26 first one, 30, 29, 21, 25, and so on, right? Can you imagine that scenario?
Yeah,
But what if we wanted 3 bins, right? Like 3 bins meaning that we're having 3 boxes to put stuff in.
we just,
That's what I'm trying to get you to tell me or
oh,
try to remember is like, because without knowing that, there's a lot of different histograms you can make. And they're, what lesson is this? 60.
62. Yeah, I'm checking it. Checking it now.
Sometimes it's the square root of the number of numbers.
Yeah, it's kind of weird because the lesson is the graphing calculator lesson, so we use those in my class. So, uh, I think it might be just. I don't know, I think it might be up to us. Hello?
Sorry. Hey, sorry. So the way to do it correctly is you take the max minus the min and you divide by the number of bins, which we'll say is 4 this time.
Uh,
So that's 3, and then you round up. So we'll go to 4, or 4, like a width of 4. So you start with your smallest number, 21, and then that's going to go to 24.9. Then your next bin is 25, go up by 4 is 28.9 to 29. And then you go up by 4, 33, which is 32.9, 33 to 36.9. So the
Okay.
width is this number 4 that I came up with, which that's the point of, but you always start with the smallest number. Then you just start counting. Okay, 25, that goes here. 30 goes here. 24 goes here, and so on.
9, 29 minus 32.9. 33 minus 36.9. Okay.
All right, now that you've got those, you can make a graph, put them on a graph here. So the first one's got a height of 2. The second one's got a height of 5. The next one's got a height of 3. And a height of 2. Then you're supposed to label this here 21, 25, 29, 33, 37. Maybe put the counts at the top.
25, 29. Okay.
I wonder if the 21-year-old was LeBron James.
Yeah.
Wonder if that.
Maybe.
But you would think, I think Dwayne Wade was, well, no, he was a little older than him. He might have been the 23. Was there a couple 21-year-olds? I thought they were about the same age.
Yeah.
Anyway, it's a side note. All right. Find the volume of a toy building block that is the shape of a cube with side length 2x plus 2 inches. All right. So first is find the area of the base. So they're saying, like, if you could just look at the base, this is 2x plus 2, and this is 2x plus 2, because it's a cube. A cube has the same length, is the same as the width, same as the height. Like if you ever made a box, you're like staring at the bottom of the box at the top there. So the product here, product is 2x plus 2 times 2x plus 2. Will you, will you foil that for us?
Okay. First. Squared. Outside. Inner. West. So 4x squared plus 4x plus 4x plus 4.
Say that one more time.
4x squared plus
Yes,
4x plus 4x plus 4.
good. So the last little piece here is to combine like terms.
Yeah.
4x squared plus 8x plus 4.
Mhm.
Part B, so that is part A. You do want to give the units here, which is inches squared, because it is an area, even though it's in symbolic form.
Yeah.
All right. Find the volume by multiplying the product found in part A by the height. So you're supposed to take this result from part A and multiply it by the height, which is 2x plus 2. So this is kind of like FOIL. Not sure if we've done it, but you're taking, and actually probably better to put this over here on the left just to maybe see it visually. You're taking each of the terms inside the first binomial and multiplying it by each of those. Okay, so that's like 8x cubed plus 16x squared plus 8x. And then it's the 2 times everything here. So that's 8x squared plus 16x plus 8. Besides color coding it here, you'll see that I've lined up the terms in like columns based on their type to make them easier to combine rather than making one large list. I find that this is a better way to show your answers.
So 8 plus 4 or 24x. Yeah, plus 24x squared plus 8 cubed. All right.
Last thing is units, inches cubed. Yeah, questions on that?
No, I'm good.
Great. All right, new question here. Verified to show that 20 comma 15 is a solution to the system of equations. This is x, this is y. So would you have to put that in for x, that in for y, and verify that it does equal 70? And then you'll do the same thing in this next one here. So guess probably better for you to work that out and see if you're convinced.
Okay. There, yeah, so the first one is true. And the second one. E. 60. Yeah, they're both a solution.
All right. Okay, so let's look at the next one here. Let me grab the graph. All right, it says for the figure, which is now below, it says find two lines that are both a line of symmetry and a perpendicular bisectors of the sides. Almost impossible for me here not to just show you what I think they're asking for. This line right here, this vertical line, bisects O and E, and then it also bisects G and F, and it meets at a right angle. There is the point of that one. And you have to come up with the equation. So for a vertical line, it's always x equals a number. In this case, it's x equals 3.
Yeah. So we need to find two lines.
Yes, the other one is going to be horizontal. So you can sort of eyeball it, or you can count. I mean, if you don't like, trying to eyeball it, but just sit there and count. The,
Oh, so it's the one like below. It's just like it's like the one that intersects y at 1.
Yeah, exactly. And that's the other one here that you got to remember is that horizontal lines are always y equals a number.
Yeah. So. Would I write the vertical line as
Yeah, I mean, I think you just have to give the equations here.
well, the slope for
You,
the
don't
what?
you don't have to find the slope. They're just asking you to find the two lines, the equations of the lines. You don't have to write like this is your answer. X equals 3 and Y equals 1. That's all they're looking for.
Yeah. That makes sense.
Sometimes some of these questions we've seen have been really difficult and some are just really straightforward. This one's got a bit more involved.
Yeah.
All right, Claudio is looking for a new job in sales. He interviews with company A and they offer him a base salary of 32,000 plus a 1.5% bonus on his total sales for the year. When he interviews with company B, they offer him a base salary of 26,000 plus 3% bonus on his total sales for the year. How much would Claudio have to sell to make the same amount at each job? All right, so your setup here is A and B. There's both some sort of a fixed and a variable part. Can you tell me what the fixed and variable part is for each one?
The fixed for A is 32,000.
Okay.
Fixed for B is 26,000.
Okay, and what's the variable part?
The 1.5% and 3%.
Yeah, now I'm going to write it as a decimal, and I know that that is not ideal here, but it is the necessary thing to do. You never work with percentages unless explicitly it says, like this is a percentage in the problem and use it as a percentage.
Mhm. So
these become two equations, 32,000 plus 0.015x, 26,000 plus 0.03x.
uh,
And we're looking for where they are the same. So how do you determine where something is the same when you're given two equations?
We by elimination.
You set them equal. You set equation 1
Is
equal
equal
to equation 2. Yeah.
to
So 32,000 plus 0.015x equals 26,000 plus 0.03x. You want to take an attempt here at solving this one?
yeah. So subtract 0.3, or I'll subtract 26,000 first. So 6,000 plus 0.15x equals 0.03x. And then divide everything by 0.03.
This you're subtracting, right? So you gotta, you should have like 6,000 equals 0.015x. Because you subtract the 0.015x.
Okay, it's because I subtracted the 26,000 first, but
Yeah.
yeah, okay, so minus 0.15 and 0.15. Does it become, or does like 6,000 is equal to negative?
No, it's 0.030. So when you subtract 0.015, it becomes 0.015.
Okay. Yeah, I just did it backwards. Kinda. Okay, so then you divide 6,000 by
By
0.
0.015, yeah. Let me know if you want some assistance on this one, how to do that.
Yeah.
All right, so first thing is you want to get rid of that decimal on the bottom. So you multiply the top and bottom by 1,000.
Uh-huh.
On the top, that just adds zeros. So it's 6 with 3
Mhm.
zeros followed by 3 more zeros. On the bottom, it's just 15. So your focus now is on something that's manageable, which is 60 divided by 15. Can you do that?
Yeah.
That's 4, followed by all those zeros you just wrote down. 3, like that.
Yep.
Okay, there's your answer. $400,000 in sales they have to come up with.
Okay.
Okay,
Do you think we get one more, like, or how much time do we have?
we got 6 minutes. We got plenty of time here.
Can I do one more, like one equation is equal to the other equation and then simplify it?
Like this. I mean, we can do, let me not make the numbers so big. Is that okay?
Yeah, yeah.
All right, let's go. I gotta make sure these work. So let's go 5x plus 0.1 x equals 3x plus 0.15 x. Yeah, that looks good. That'll work out.
Oh, 0.15x. So 2x equals 0.05x.
0.05x, that's right.
Yeah.
And so you're gonna, I'm sorry.
Yeah, no.
I'm sorry. I really messed this up. It should be, I lost my mind here. It should be 5 and 3. So we're gonna make a quick change to just making that 2 equals 0.05x.
Yeah.
Okay. And then you're gonna divide both sides by 0.05. And you can try using that technique we just talked about.
So multiply everything, or the top and the bottom,
This time, what are you gonna multiply by? It's not 1,000. It's based on the number of decimal points you got.
by 100.
By 100. So that becomes 200 over 5.
And then 440.
Yes.
Yeah. All right, that makes more sense to me now.
Okay.
We can do 19.
Okay. All right. So 19 here. All right. The second equation, a system of equations, is formed by adding a non-zero number to one side of the first equation. So let's just use something really simple, like y equals 2x plus 3. Okay. That's our first equation. And I just made that up. There's nothing special about that. The second equation is formed by adding a non-zero number to one side of the first equation. So I'm going to rewrite the first equation and I'm going to add a non-zero number. You're going to pick the non-zero number for us. Anything but 0.
Yeah, 2.
Okay, so plus 2. Okay, so this becomes y equals 2x plus 5. And the first equation is still y equals 2x plus 7.
Mhm.
These equations have the same slope. They have the same slope here, but a different y-intercept.
X plus 5, yeah.
So the graph of the first one is, all right, there's 7, slope of 2, something like that. The second one is 5, slope of 2, something like that. Parallel. So these do not intersect. I'm not sure what they mean by classify the system. They might be looking for words like consistent or inconsistent.
Yeah, that's what they mean.
Okay, so quick review on that. Consistent is when there is one solution when they intersect. Inconsistent is when there is no solution, which is the case when they are parallel.
So yeah, inconsistent. And we can do 20.
Yep. All right, go. Determine if the lines are parallel or perpendicular. That is based on the slope.
So
Slope. What's the slope of the first one?
3x.
It's a number, just 3.
And then
On the second one, you really should get it into y equals mx plus b format. What is its slope?
3.
Are they the same?
Yeah, so they're parallel.
They're parallel. All right. Probably won't be able to do any more today. So we'll have to go ahead and stop here.